Okay, this time I have cosine t on the right side, and that's going to be a little challenging. All right, so let's try this. First, Laplace transform. This turns into s squared y of s minus s y of 0 minus y prime of 0 plus 5 times s of y of s minus y of 0. That's this. And then the last one is just 4 times y of s equal to 17. Let's see, what's the Laplace transform of cosine? It's this thing, right, with k equal to 1. So it's s over s squared plus 1. Okay. Now let's plug in the initial points, initial conditions. It's s times negative 1 minus 2 plus 5 times, actually this is 5s y of s minus 5 times y of 0, which is negative 1, plus 4 times y of s, 17s over s squared plus 1. Hopefully my 5 and s's look different. Collect all the y(s). So this are collected to become s squared plus 5s plus 4 y of s. This is s, that should be moved to the other side. Negative s. Negative 2 plus 5 is 3, but positive 3, if you go to the other side, it's negative 3. Plus 17s over s squared plus 1. And finally, if you divide this to the other side, this is what you get. You can divide this by this, which gives you negative s minus 3 over s squared plus 5s plus 4 plus the 17s over s squared plus 1 should also be divided by this, so it'll be s squared plus 5s plus 4. Now, another thing that you can do is you can combine these two into a single fraction by multiplying s squared plus 1 top and bottom. But that's not necessary because we are in the business of splitting out fractions, not putting fractions together, right? So we're not really interested in putting it together. But if you pretend that they're all together, then you kind of see what kind of fraction you want to split this into. You need s squared plus 1, so here's what you are aiming for. You want something over s squared plus 1 plus something over, well, what is this? This is s plus 1 times s plus 4, right? So you would need something over s plus 1 plus something over s plus 4. Okay, so these are the things that you need. Now let's try to fill in the top parts. If you have s squared, what do you put on the top? You can't just put a there, right? What do you have to do? You need a polynomial that's 1 degree less than the bottom. See, this is a second order polynomial, right? So you want to put as plus b. How about this one? C. This is first order, so the degree 0, this is degree 1, and degree 0 polynomial is just a constant. You put a d here, again. So that's what you need. And our goal is to figure out what A, B, C, and D are. And once you figure them out, then you can work this table backwards to figure out what your y of t is. Okay? So let's do that. And we're going to try to just apply that method of just multiplying the denominator to the other side, and then you keep plugging in values So let's see if that method works. Okay, so I'm going to multiply this thing to every term that you see. This, 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 this. All of them should be multiplied by this. Now, if I multiply this to the first one, this will cancel out, but this will live, right? So you're going to have s squared plus 1 times negative s minus 3. On the right side, you have as plus b times s plus 1 times s plus 4. And then c times s squared plus 1 times s plus 4. Just remember, it's you're really multiplying s squared plus 1 times s plus 1 times s plus 4 to each of these terms. So if I multiply this to this one, what's going to happen? S plus 1 and s plus 1 will cancel, leaving you with s squared plus 1 times s plus 4. That's what I have here. Okay. And then again, for d, it will be what? Can you tell me what you get?
S squared plus 1.
S plus 1.
S squared plus 1. S plus 1.
S plus 1. Yes. That's what you're going to get. Okay. So we have this huge equation, and I'm going to start out by plugging in values. What's a good value to plug in? S equal to?
1.
I would say negative 1. Why negative 1? Because this is going to go away if I plug in negative 1. This will also go away. See, negative 1 plus 1 is 0. So if I plug in negative 1, this is 0 times something, so I don't even have to compute the other ones. It will be completely 0, and the only survivor will be this one. Okay? So that's the beauty of this plugging in method. Okay? So if I have s equal to negative 1, let's see, this is negative 1 squared, which is 1. 1 plus 1 is 2, times negative 1 minus 3. Negative of negative 1 is positive 1. 1 minus 3 is negative 2. And 17 times negative 1, which is negative 17. I'll just write negative 17. On the other side, this is 0, that's 0. The only survivor is this one, which is c times 2 times negative 1 plus 4 is 3. Okay. What's that? That's negative 4 minus 17, negative 21. Equals to c times 6. So c is negative 21 over 6. And you can reduce this because top and bottom is both divisible by 3. If I divide top and bottom by 3, you get negative 7 over 2. Okay. So that's a very easy way to get unknown coefficients. Now what should I do? What other number should I plug in?
Negative 4.
Negative 4, of course. That will make this equal to 0, right? Negative 4 plus 4 will be 0. So in that case, this will be 0, that will be 0, and d will be the only survivor. So let's do that. Negative 4 squared is 16 plus 1. So that's 17. Negative of negative is positive 4. 4 minus 3 is 1. And 17 times negative 4. What's 17 times negative 4? Negative 52? No, 58, right? No, 68, 16. Yeah. Okay, well, we'll calculate that later. On the right side, this will be 0, that will be 0, because negative 4 plus 4 is 0. Negative 4, that's 17, and this is negative 4 plus 1 is negative 3. So it's d times 17 times negative 3. Oh. I like this. 17 is comma, so I can just factor it out. So I have 1 minus 4, which is negative 3, equals to d times negative 3, so you get d equals to 1. Okay? All right, so we had, so this one was obtained by setting s equal to negative 4. So we had some fun plugging in and getting rid of a lot of variables, but the fun is over. Now you ran out of nice numbers to plug in. Do you see that, right? I mean, okay, I guess taking s equal to 0 might get rid of a. right? Still. But it's not as fun as before. You still have a lot. Okay, so let's do that. So let's take advantage of that one. S equal to 0. That's 1 times -3, so it's -3. And 17 times 0 is 0, so that's the only thing you get on the left side. On the right side, if you plug in 0 here, you only get b times 1 times 4, so it's 4b. And then if I plug in 0, that's 4c. And then 0, 0, it's d. Let's plug in the values we got for c and d. C is -7/2, and d is 1. This cancels, so it's this is -14. Let's see, -13. Move it over, +13. So it's 10 equals to 4b. So you get b equals to 10/4, which is 5/2. Okay. All right. So we had some fun with these numbers where some variables disappear. However, we still need to find out a, and we ran out of numbers. If that happens, then that's when you use the coefficient comparison method. Okay? So you want to compare the correct coefficient, and by doing that, you can find out what a is. However, we all know that comparing coefficient requires this expanding everything, right? And organizing everything in terms of s powers of s, and that's a very long procedure, and you don't want to be spending all the time. After all, we're plugging in these numbers so that we can avoid the coefficient comparison, right? So this is what we're going to do. Instead of expanding everything, just imagine what will be giving us the highest order term. Okay? So what's the highest order term if you expanded this in terms of s?
A.
Yeah, so s to what power would be the highest order? If you FOIL this out, right? This will give you s squared, that's the highest order, right? But if you multiply it with this, you're going to get
Cubed.
s cubed, right? So the highest order term that's going to be produced from here is s cubed with what coefficient?
A.
As cubed, right? How about this one? Cs cubed. How about this one? ds cubed. So, despite the fact that we did not expand everything and did all the math, we can still figure out that on the right side, we're going to have as cubed plus bs cubed plus, cs cubed plus ds cubed. That's the highest order term on the left, right? How about the left side? Do you see s cubed here? S squared times -s, right? So you have negative s cubed on the left side. So this is what happens to the s cubed term. And that's a very good idea. Because the highest order term is often not so hard to figure out, you can skip the process of having to expand everything and just look at the highest order term. So we look at that and say, hey, if I divide everything by s cubed, I get -1 equals to a plus c plus d. And I already know what c is. C is -7/2. And d is 1. A is this. So if I move this to the other side, it's -2 plus 7/2 equal to a. -4/2, so it's 3/2. So a is 3/2. That's what a is. Okay? And wonderful, we found everything. A, B, C, D, E. So we get to plug them back in. And by the way, I even want to split this into two terms. So rather than writing it like that, I want to write down A is 3/2 plus B is 5/2 s squared plus 1 plus c over, c is negative 7 over 2, and d is 1. Okay? So that's what I got. That's my y of s. Okay, do you have any questions so far? All right. Then we are in a perfect position to find what y of t is. So let's try that. What's y of t? Y of t is is 3 over 2. What gives you this? S over s squared plus 1.
Cosine.
Cosine, right? It's cosine 1. Okay, what gives you 1 over s squared plus 1? Sine 1t, right? So it's sine t. And then minus 7 over 2. What gives you 1 over s plus 1?
E.
E to the negative t. And finally, 1 times e to the it's s plus 4. So this is s plus 4 is s minus what?
And
Negative 4. So what goes here? Negative
14.
14. And that's it. That's the answer.